Good morning, dear students. My name is Ferhan Mazher, and the topic we are working on is further differentiation, and we are working on the topic of the practical application of the connected rates of change. We are working on the chapter number 8, and it's exercise 8E. And in this video, we are going to start from the question number 9. In the question number 9, you see the question is, water is poured into the hemispherical bowl of the radius 5 centimeter at a rate of 3 pi centimeter cube per second. After t seconds, the volume of the water in the bowl, comma, v centimeter cube is given by v is equals to 5 pi h square minus 1 by 3 pi h cube, where h centimeter is the height of the water in the bowl. Find the rate of change of h when the h is equals to 1. Find the rate of change of the h when the h is equals to 3. So this is the question they are asking us. So now what we will do, we will try to solve this. And so let's start our work. So water is poured into the hemispherical okay, the formula is given. This is the question number 9 of the exercise 8E. This is basically the exercise 8E, and this is further differentiation. The chapter is further differentiation. It's question number 9. Water is poured into hemispherical bowl of the radius 5 centimeter at a rate of, okay, the dv by the dt is given, that is equals to 3 pi centimeter cube per second. So their question is, after t seconds, the volume of the water in the bowl is v centimeter cube is given by. The formula for the volume is given. Volume is equals to 5 pi h square minus 1 by 3 pi h cube. This formula is given in the question, and he says where 8 centimeter is the height of the water in the bowl. Find the rate of the change of the h, and their question is what is dh by dt. They have given us two values of the h, on which we have to find out the value of the the dh by the dt. Now because this formula is given, I can differentiate it. dv by the dh, that will be equals to 5 and pi, and the 2 will come on the side, and then you will have h minus 1 by 3 pi, and then this 3 will come on the side, and h raised to power 2. So your dv by the dh, that will become this becomes 10 pi h minus 3 3's are cancelled, so it will becomes pi h square. So this is the formula for the v by the dh. Okay, so now what we will do, we will when the h is equals to 1, when h is equals to 1, what will be the value of the dv by the dh? That will be equals to 10 pi h is 1 minus pi h is 1 and its square. So the value of the dv by the dh will be equals to, this is 10 pi minus 1 pi, you are left with the 9 pi. Okay, so this is the value of the dv by the dh when h is equals to 1. So we can find the dh by the dt. This is the main question. That will be equals to the the dv by the dt into the you reciprocate this thing, dh by the dv. Okay, so this is my chain rule. I have written that chain rule. Okay, now you will have dh by the dt, and that will be equals to the dv by the dt, that is given, that is 3 pi into, and the dh by dv will be reciprocal of this thing, so it will become 1 by 9 pi. Pi will be cancelled, so dh by the dt is equals to 1 by 3. So this is that first question, first part of that question. Then they ask find the rate of the change of the h when the h is equals to 3. Okay, So when h is equals to 3, so dv by the dh, that is equals to the 10 into the pi, and the h value is 3 minus pi and 3 square. So you will have dv by the dh equals to, this will become 30 pi minus 9 pi. So when you do this dv by the dh, 30 pi minus 9 pi, what will be that? That will be 21 pi. Yeah, 21 pi. Now I will apply the chain rule. According to the chain rule, you see what is dh by the dt, that is the question. That will be equals to the dv by the dt into the dh by the dt. dv, sorry. Okay, so the dh by the dt, that will be equals to dv by the dt, that is 3 pi, that was given here, and the value of the dh by dv when the h is equals to 3, that will be 1 by 21 pi. Okay, pi will be cancelled, so the dh by dt, that will be equals to 1 by 7, and centimeter, this will be centimeter per second, this will be also centimeter per second. So this is their question. That was the question number 9 from the exercise 8e. This is the course book of the Pure Maths 1. This is the syllabus content of the paper 1, and let me check the answer, sir, from the book. Okay, so we are working on the exercise 8e, and it's question number 9. So you can see the question number 9, it's answer 9, 1 by 3 centimeter per second, and B part is 1 by 7 centimeter per second. So this is how you do question number 9 of the exercise 8e. So thank you very much for watching this video. My name is Ferhan Mazher, and you know that I was just trying to check that if we can make the video in this way. Just I'm just testing it. That's why I'm only doing one question in this video. So we will see that how this video goes on. So thank you very much for taking your time and watching this video and preparing your AS Mathematics from my YouTube channel. Thank you very much. Have a good day. God bless you all.